Hello, everyone. My name is Qiu Bai. I'm a PhD student from UC Irvine. Today, I will do a demo presentation of our work, VisBooster, accelerating Tableau live mode queries up to 100 times faster. This work was done jointly with my colleague, Sadim Alsudais, and my advisor, Professor Chen Li. Suppose I am a Tableau user, and I want to analyze 30 million tweets that are stored in a PostgreSQL database. I opened up this Tableau window on the left top of the screen with the dashboard. In this dashboard, I have a text filter with iPhone as the keyword to filter the tweets. I then show the spatial distribution on the left, and then the temporal distribution on the right. Suppose I'm interested in the 3 quarters in the bar chart that have the highest frequency of iPhone-related tweets. I will click these 3 bars to further filter the tweets. Once I click these 3 bars, Tableau pops up this timer window, which shows the query's execution time. What happens behind the scene is that Tableau formulates this visualization query into a SQL query, denoted as Q. It sends the query Q to the backend database through a JDBC driver. The database runs the query Q and then returns the result back to Tableau through the same JDBC driver. Then Tableau re-renders the result to the user. And this is the life cycle for a Tableau live mode query. As we can see, the query is just finished, which took more than 40 seconds. Clearly, this is a too long delay for such an interactive visualization dashboard. To solve this problem, we introduce VisBooster. VisBooster is a middleware-based query rewriting framework. To use VisBooster, we first replace the original JDBC driver with a slightly customized version. The new driver intercepts all queries passing through it. It sends the original query Q to the VisBooster server. VisBooster server then rewrites the original query Q into a new query Q prime by applying a bunch of rewriting rules. The new driver then sends the new query Q prime to the database, and the database runs the new query Q prime and returns the result back to Tableau. In VisBooster, we only focus on equivalent query rewriting, which means the result of the new query Q prime is exactly the same as the original query Q. Now let's see the performance of using VisBooster sitting in between the Tableau and the database. To use VisBooster, we first opens up this VisBooster web interface. The user goes to the JDBC drivers page and download the corresponding JDBC driver file for their database. In our case, we download the PostgreSQL JDBC driver, and we replace the original jar file in the Tableau folder with the new driver. The user then goes to the rewriting rules page. On this page, we can see VisBooster provides a few rewriting rules that have already implemented. By clicking the button here, the user can enable or disable a specific rewriting rule. In our case, we enable the first 2 rewriting rules to accelerate the aforementioned query. Now I open up a new Tableau window with exactly the same dashboard as before. And with the 2 rewriting rules enabled, let me issue the same query as before again. I will click these 3 bars. Once I click these 3 bars, you can see the Tableau doesn't even pop up the timer window, and the query is done instantly, which is significantly faster than before. Let me show you a new query to see the difference again. I will click this bar to see the query, to issue a new query. As you can see, the query is done immediately with the left visualization updated also. Now let me go back to the VisBooster dashboard and disable these two rules again. And now with all the rules disabled, VisBooster will not rewrite the query at all. And then I go back to the dashboard of Tableau and click one of the bars to issue a new query. And as you can see, the timer window is popped up again, and the query is significantly slower. Now let's answer the question, how does VisBooster rewrite the original query into a much more efficient one? The first demoed query is shown on the left. This is the original query with the two filtering predicates. One is on the time dimension to filter the tweets within the 3 quarters. And the second is on the text dimension to do the keyword search for iPhone. And the physical plan is shown at the bottom. You can see it uses a sequential scan on the raw table, which is not surprisingly too slow. We have enabled the two rewriting rules. The first rule, number 1, will remove the typecasting function call from the original query. As we can see, the original query will cast the time dimension column into date type. And this is inserted by Tableau automatically because Tableau needs to avoid any errors from the database. For example, data type mismatching or date overflow. And the corresponding rewritten query Q prime, but after applying the rule number 1, is shown on the right. Since we know that the schema of the database, so we can safely remove the typecasting function call without any problem. And the new query Q prime has the physical plan shown at the bottom. As we can see, it uses index scan on the time dimension, which is much faster than the sequential scan on the raw table. And it turns out that the Q prime took 7 seconds, while the original query took more than 30 seconds. However, 7 seconds is still not fast enough. So we have enabled the second rewriting rule. The second rule will replace the keyword search predicate from a string position function call to a like predicate. And the corresponding rewritten query Q double prime is shown on the right. It turns out that the physical plan of the Q double prime uses both indexes on the text dimension and the time dimension to do the filtering first. And this turns out to be significantly faster. The Q double prime only took less than 300 milliseconds to finish, compared with the original query that took more than 30 seconds to finish. And this new query is 100 times faster than before. To summarize, VisBooster provides the following benefits. First, it requires no code change to Tableau or the database. Second, by involving human in the loop, VisBooster can leverage human wisdom in query rewriting. And finally, it is very flexible for the users to add and control the rules. We have more details and the demo cases in our paper. VisBooster is also open source at the following link. With VisBooster can significantly accelerate Tableau live mode queries. It also opens up some research questions for our future work. For example, how to help the users to find those rewriting rules, how to allow the users to express their rules easily. For an online query, how can VisBooster select a subset of rules that can be applied on the query, and in what order to apply the rules? Finally, how to protect the users' privacy, especially their queries. This concludes my presentation. Thank you for your attention.